as number 3, we're doing something very, very similar. It's about a propeller-driven aircraft, which does not matter. But the speed we're looking at is going to be 925 kilometers per hour. Excuse the sloppy writing. So our first vector is it travels straight east for 1.5 hours. So here's our first vector. We don't have to do anything else besides multiply this by the length of time, as distance is rate over time. And for that, we're going to end up getting 1387.5 kilometers. The second one is a little tricky, as it's going to travel 135 degrees northwest. Drawing our coordinate plane, so we're always going to start from the positive coordinate here. This would be 90. 135 is going to be about here, as a whole trip around halfway would be 180. So it's going to be something like this, as this angle in relation is going to be 135. But that's not important to us, as we know from geometry, hopefully, that the supplementary angle, this is going to be a 45 degree, and now we can draw our triangle from there. Keep in mind, however, since we went to the left from this bottom, whatever we get here is going to be negative. So we have to travel 2 hours, so multiply this number by 2 to get our hypotenuse here, and it's going to be 1850. And now we can do our classic trig. Oh Jesus, that's bad. Hold on. Sine 45 is going to equal our opposite over our hypotenuse. And we end up doing the math here, multiplying sine function by 1850. To get the opposite side, we're going to be getting 1308.1. Now, an interesting thing was brought up to me in class, as I did not think about this at all. But this is a 45-90 triangle. So we already know, we don't have to do any math, that these sides are going to be the same. I calculated it myself using the cosine thing, or the cosine feature, and I got the same exact answer. I completely overlooked the fact that this would be a 45-90 triangle, and these two sides are going to be the same. However, this is negative as it is going to the left. So we can finally draw our resultant vector here, as we still need to find theta. This is going to be our right angle. Doing the addition here, you may be confused, as this y, this vector over here, does not have a y, so it's considered 0. So we're just going to translate over our y value from over here. And after adding both directions, we're going to end up getting 79.42. And now we do the classic Pythagorean theorem, find out our hypotenuse. Pretty sure you guys are starting to catch on by now. After you solve this for c, do the square root, you're going to be getting 1310. And, geez. To solve for theta, again, we're going to be doing the inverse tangent. Here's theta, our opposite, over our adjacent. Now the answer sheet had this backwards, so pay very close mind to this. The answer sheet says 3.5 or something like that, and that's because when the answer sheet did this, they did this instead of the correct way, like I'm doing. So the answer sheet, unfortunately, is wrong. So there's that. I'm now going to write our final answer. After you solve that tangent function there, you're going to be getting 1310 kilometers at 86.5 degrees northeast. And there's your final answer for number 3.